Welcome to a new video from the DARKSPINE tutorial series. In this tutorial we will talk about the friction joint, but we will also pause along the way to talk about DARKSPINE's current performance. So we will make a brief explanation of the friction joint and we will make a test at our level. The friction joint is very simple. We must assign the coordinates of our joint, the force and torque of our engine. This will create the illusion that forces pushes in the opposite direction to gravity. In this case we get the platform to fall smoothly, but if we assign a higher value to the torque motor, our platform will be floating in the air. This may come in handy to create an example such as being suspended on a stream of water. There is not much else to add. Now I want to show you a small performance test, and for that we will load another level. Here we have a land which we have become a father. The hierarchy contains 2 terrains, 2 fences, 8 trees, 8 particle system with 2 particles each, and a bridge generated with physics. What we are going to do is copy this hierarchy until it reaches about 1000 objects and check the drawing efficiency. For this we will use the default function to visualize our performance. It should be noted that we are not using the YoYo compiler. In the description of this video I will leave you the specification of my computer. And we already have our first results. In the editor mode and without applying any optimization, we get 209 texture swaps, 657 vertex batches and an average of 110 frames per second. In test mode, we get a result of 125 texture swaps, 212 vertex batches and an average of 100 frames per second. Understanding how GameMaker draws our assets, I have decided to design a script to optimize the graphics pipeline. For the moment, this function reduces the number of texture swaps in the processes of our graphics card. This script we will improve, offering the possibility of reducing the number of vertex batches. Simply by pressing the F1 key, this script will be executed automatically, fulfilling its function. These are the results after optimization. In the editor mode we get 113 texture swaps, 623 vertex batches and an average of 170 frames per second. In test mode we get 77 texture swaps, 212 vertex batches and an average of 100 frames per second. As you can see, there is a lot of room to create large scenarios. With the help of object scripting, our editor and the GameMaker functions, we can easily design a system to draw only the visual area in which we are located. Later we will deepen in how to program objects to later use them in our editor and benefit from being able to change values in real time. This is all for now. In the following video we will see how the folder of our working directory is structured. Thanks for watching and see you soon!